Alright guys, so I'm going to continue our work with functions. Last time we looked at input, output, function notation, things like that. Today we're looking at what's domain and what is range, and specifically how to know what that is by looking at a graph. We're also going to look at evaluating versus solving, so hopefully by the end of the day you guys can explain to me the difference between evaluating a function and solving for a function. And we're going to be doing that in the three ways to represent a function, right? You can evaluate and solve when you have an equation, a table, or a graph. So those are our objectives for the day. So here's this. Did I print this slide for you? Do you guys have blanks that you need to fill in, or is it all complete? Okay, cool. All right, so domain is all the possible values of x that can work for a function. So if I were to give you guys something like this, you can't just plug anything you want in for x here. There's a limit on what you're allowed to plug in for x. What's the limit? Like, what's something you can't plug in for x here? You can do 0, because 0 does have a square root, but that's a tricky one. So, yeah, a prime number. So, believe it or not, it's a funny one. We don't like those, so I see why you say that. But there's an answer to this. So, like the square root of 3, I like your answer though. But the square root of 3 actually does have a square root, and if you want to know what it is, just get out your cell phone and push square root of 3. You'll get an answer. It's just an irrational number. It's really funky looking, but it's there. It exists. What else? A negative number. Now that's true. You can't plug in any negatives. Here's why. Because what a square root is, like if I gave you guys this, you know the answer is 8, right? Because what you're looking for is a number times itself. It makes 64, right? So if I were to plug in a negative number, well, I'm looking for what number multiplied by itself. In other words, like what times itself would give me 64? Well, that would be x squared. But you guys know that no matter what happens, when you square something, it always comes out what? Positive. So there's no way you could ever multiply something by itself and get a negative, right? Like if you had -8, -8, it's a positive. +8, +8, it's a positive. And then somebody tries to always throw in, well, what about 8 and -8? You say, well, that's fine, but that's not the same number, is it? So you're looking for a number that times itself will give it. So it's not possible to get a negative. So you're right, Kalani. So you can't have anything for x here, just anything. It has to be specifically 0 or higher. So positive or 0. Also, because x is limited, remember how we talked about this is called the independent variable, right? It gets to kind of decide what to be. Well, this guy is called the what? Dependent variable. And so a lot of times if your independent variable is limited, guess what happens to your dependent variable? It also gets limited. You could never take a square root and get a positive out of it, or I'm sorry, a negative. So that's also limited. So domain and range is basically all the possible values of x for a function and all the possible values of y for a function. And that's kind of important to know. Why is it important to know what your domain and range is? Because a lot of times when you're doing math, you can end up with answers that aren't actually real answers. They're called extraneous solutions. And so if you're aware of what your domain and range is, you can be aware of which ones are allowed and which ones are not. So that is a possibility. Yeah, what's up?
Okay, so how do you still figure out that this specific thing is the input and this is the output? Is it like whatever's on the left side of the equation is going to be input? Or how do you figure that out?
That's a good question. So that's a question for last class, so I'll pause our video here for that. Now specifically, guys, the way we're going to be finding the domain and ranges of functions today is by looking at graphs. You can tell what the possible values of x are and what the possible values of y are by looking at graphs. Okay? Now, you guys know that x is on the horizontal axis, right? So if you want to know by looking at a graph what your domain is, you just have to ask, so how far to the left and how far to the right is my graph going? Okay, and I'll show you a few examples. Y is the output variable and it goes on the vertical axis, right? So if you want to know what your range is, you just have to look at how far up and down your graph goes. Okay? And so this is how our answer is always going to look. You're going to have a number for here to represent how far to the left it goes. You're going to have a number here to represent how far to the right it goes. And then x goes in the middle, and that's your domain. For the range, you're going to have a number here to represent how far down the graph goes. This one represents how far up it goes. You have another number, and then you have y in the middle, and that's your range. So that's domain and range. Let's put that to work for us here. Did I print any of these graphs for you? Yeah. I did?
Oh,
No, I didn't. All right. So you guys have student practice on your notes today, though. Okay, and that's so when we do it. Usually, I print examples, and I don't do student practice. Today I did it opposite. So today, just watch, and if there's some notes you want to take as you go ahead. But I probably won't be giving you time to write down the whole graph. But just pay attention, and then when we do student practice, make sure that your answers are correct, because that's going to serve as your notes for later, okay? All right, so let's go ahead and do this here. So I want to find my domain. Domain is going to be how far to the left and right does my graph go. So if I ask you guys to come up here and find the point that's furthest to the left, you would circle this one, correct? Now, what number is there? What's the x number there? -3. So that's the farthest point to the left that this graph goes. What do you think I'm going to put for the one on the right? 1. My furthest point to the right is here, correct? And so the x value for that point is 1. So as you guys can see, are there any holes in here? Are there any gaps anywhere? Or is that a nice continuous line? Because you do have to, I probably won't be giving those things too tricky like that, but if there's holes, you have to put this plus, but not that. If you got any holes or gaps, you have to somehow state that they're there. But you guys see that x value can be anything from -3 all the way up to 1. So my possible values of x are from -3 to 1. And that's our domain. Okay, now here's another thing. This may be something you need a note on. I don't know. Do you guys notice a difference between these endpoints? It's kind of hard to see from where you are, maybe. What's the difference? One, I didn't hear you, but I'll state it. And this is a open dot, right? And that's a closed dot. You guys remember what open means? There's not a point there. So can x equal a -3? No, it can't. But over here we've got a closed dot. Can x equal 1? So guess what we do? You need to put a little line there. So x can be anything from -3, but not including -3, all the way up to 1, including 1. Okay? So those are your possible values of x. Now let's take a look at my range. Now when you're doing your range, it's y, right? We're talking about the y values. And instead of going from furthest point to the left and furthest point to the right, we're going furthest point down and furthest point up. So what would you guys say is the lowest point on this graph? Like if I actually come up here and circle it, would you guys agree that that's reasonable? How about this? They're the same, aren't they? But that doesn't matter if there's more than one. The point is, what's the lowest value on the graph? Now, it's a y value, correct? So what's the y value of this lowest point? It's -4. What's the highest point on the graph?
0.
It's 0. Now let me ask you guys, that's here. There's a 0 and also here, right? Now let me ask you guys, can x equal -4?
Okay.
Let's see. Here's -4, right? Here's one of them. Is it a closed dot?
Yes.
We're good. Can x equal 0? I expect to get some mixed answers here. Because if I said here, you would say what? But can it equal 0 here? It can. So actually 0 is allowed because of that other point. Okay? So there is a place where y can equal 0. Okay? It can't equal 0 here, but it can equal 0 here. So the question is, can it equal 0 somewhere? Yes, it can. So
Why do we need that little line over there?
which one? This one?
Yeah.
Because that's this point, right? And it's a closed dot. So when you have a closed dot, use a line.
If you don't have a closed dot.
Like this one, no line.
Okay, so -4, wasn't that a closed dot?
Yep.
So do we have a line for that too?
I should have. I didn't put it. Thank you. Good obs. I owe you a point. Any other questions? All right, so there it is, domain and range. So x and y can be anything between these values, okay? All right, let's do another one. You guys see something different on this graph that wasn't on the last graph? What do you see that's different on this? Huh? Arrows. What do arrows mean? It just keeps going. It never stops. Okay, so let's do domain and range. Actually, let's start with, let's do range first this time. I think it's a little less confusing, and then we'll work our way up to the domain. So what's the lowest point on this graph? Huh? It's infinite, right? There is no low. It just keeps going. And so what we're going to do is we're going to put infinity, but it's going which way? So it's going to be negative infinity. Can you reach infinity? No, it doesn't make sense, actually. Infinity is infinity. So if you got there, it wouldn't be infinity, right? So are we going to put an equal sign here? No, y can't equal infinity. It can approach infinity. It can be close to it. It can go that way, but it can never get there, right? All right, what's the highest value on the graph? 10. Can it equal 10? There we go. We got our range. So y can be anything from negative infinity all the way up to 10. Well, actually, though, I guess we should check. Are there any gaps in here or holes that we need to take in mind?
No.
No. Okay, we're good. Huh? Not that we can see. That's a good point. What if there's a whole gap somewhere down there?
Okay, so why don't you put infinity? Isn't it 0 for the lowest point?
No. Here's 0, right?
Yeah.
So here's our highest point. Here's 0. You agree? But there's some y values underneath of that. And in fact, it keeps going. Okay. All right. Let's go ahead and do the domain. Now, the reason why I feel like this one's a little bit confusing is just because it's very subtle. What's the farthest point to the right that this graph goes? Well, I'll tell you. I won't make the answer. Is this thing going straight down or is it spreading out? It is. It's spreading out. Okay. Now, there is such a thing as an asymptote. If there was an asymptote, that would be like a limit. It can't go past that line. But we don't really have an asymptote there. So even though it looks really straight, the point is, do you guys see how it's getting wider? We can assume it keeps getting wider very slowly, but it does keep getting wider. And so I can assume that even though it's going very slowly, it does keep creeping to the right more and more and more, and there's no reason for me to assume that it stops. So what am I going to put here? You're going to put infinity. And it's going to the right, so am I going to put positive infinity or negative? Positive infinity. You don't need to put a plus, but you can. All right, what do you think about the left side? Negative infinity, right? Now, what's another word for this? If x can be anything from negative infinity to positive infinity, x can be? Well, x can be positive, but it can be anything. And so what we can say here is, so there's no limit on what x is allowed to be. X can be anything. Okay? Unless, like Braden was saying, maybe on the part of the graph we can't see if there's a hole or a gap somewhere. But for now, we can assume that it's complete. All right, let's go ahead and do another one. Why don't you guys try this one a little bit, just as like a an individual practice real quick. You don't have to write it down on your notes, but write it somewhere so that when I call on you, you have a thought to share. Don't draw the graph, okay? Just tell me, I want to know what goes in these blanks. Blank, 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 blank. And also, don't forget, should I put equal signs underneath of these, okay? What'd you put for this number here? That's right. The graph never stops going to the left. You can see there's an arrow there. Never stops. Giovanni Ramirez. Oh, I've got two Giovannis in another class, and so there's one there, and I was like, I don't see either one, but I remember now. Okay, Giovanni. What'd you put here? 5. He's right. The graph stops right there. Let me ask another person here for something else. Zanab, do I put an equal here? Here? Good. That's right, because it can equal 5. It can't equal negative infinity. All right, how about Ashley? What'd you put here? Yep, the graph never stops going down. Never stops going down. Quinn, what'd you put here? 2. The highest y value is 2. Okay, that happens right here. I don't think Amaya's with us today. So let me ask Amber. Do I put an equal sign here? How about here? Good, because it's a closed dot. We'll put an equal. So you guys have the idea. I think there's one more thing before I set you loose on student practice is those asymptotes I was telling you about. So let's look at this one. Domain. Okay. Does it ever stop going to the left? No. Does it ever stop going to the right? There's an arrow there. It keeps going. So we say all real numbers, right? Range. This one's interesting. Does it ever stop going up? Nope. And that's a positive infinity, right? Keeps going up. Now, this is what's called an asymptote. You guys remember those? Is that familiar to you guys at all? It's an imaginary line that the graph is approaching, but it can't reach. Okay. So, what is that boundary? What's it trying to reach? The lowest point would be 0, right? The y value. It's going, it starts way up here and it gets closer and closer to y equals 0. But here's the kicker. Do I put equals there?
Yes.
No. So that's the one thing I want you guys to walk away from with asymptotes. It can't touch an asymptote. So it gets closer and closer to it, but it never gets to 0.
So it's a point.
It's an invisible line that it can't touch. So it's getting closer and closer. It's kind of like me doing this.
It's like running from that face.
We'll be here forever. I'll keep trying to poke your forehead, but I'll never get there. So, all right. So
you'll get like right here.
Yeah.
And then like never touch it.
Yeah. Every time I get closer, I still get closer every time, but a little less every time.
We should try it in public. It's kind of people.
That's how you make friends.
See how we do.
Okay. So see how you guys do with these guys here. I will tell you that number three's domain is just try to do what you can with it. There is an x value that it cannot equal. Okay, and so you have to be kind of creative how you write it. I didn't do an example quite like that. But remember, all domain is saying what are the possible values of x. The other two, 1 and 2, you guys should nail those. Number 3, the domain's the domain and the range they're weird because they do have a value they can't equal. I'll let you guys see if you can figure out how to write them there. All right, so let's talk about the part that I saw a few people having trouble with first, and that's on number 2, domain. So here we go. George, what did you put for the number here to the left of the x? 1. Okay, now that trips some people up because this point is the furthest to the left, right? But what tripped a few people up out there was the fact that this is an open dot. And so they thought, I can't put 1. It's not there. And that's good thinking, you're right. But it's still not there, even though I wrote the number here. You know why? Because I didn't put equals to there. So it's the difference between it's a boundary, right? You guys agree that everything stops here, right? So that is a boundary. So the analogy I like to use is kind of like the difference between a brick wall and an electric fence. Can you touch a brick wall?
Yeah.
You can touch a brick wall. Can you touch an electric fence?
No.
You shouldn't touch an electric fence. But it's still a boundary, right? So in this case, I've got an electric fence. My electric fence is at 1, but we don't want to touch it. Okay? All right, and so let's continue the journey here. Edward, let's try Nicole. What'd you put over here? 4. So the x value that's furthest to the right is this one, which is x equals 4. So basically, x could be anything 1 to 4. Is this a brick wall or an electric fence?
Brick wall.
So x can equal 4. It can touch 4. All right, let's do the next one. Madison, if it's a brick wall, yeah. All right, Madison, what'd you put for this one? I'm gonna let you do both for me here. 1 and 7, good. And 1 is still an electric fence, right? But 7 is still a brick wall. So there's your answer there. Okay. So that was the part that it was the ones that were kind of throwing people. They felt like I shouldn't be able to put 1 if it's not there. That's like saying, well, the fence is there, you just can't touch it, right? All right. Jason, what was your domain for this one? It went from what to what?
-8 to infinity.
Good. It's the furthest point to the left is -8, and it keeps going to the right, and it can equal a -8, right? Let's do another one here. How about Amanda Deep? What did you get for your range on this one? 0 and what? That's right. It's the lowest y value is here at 0, and it can equal 0, but it keeps going up after that. You guys see how it keeps going up? And since there's an arrow, we can assume it keeps going up. It's going very, very slowly, but it is going up. All right, so there's that. As for this guy here, the domain, basically what we have is x goes to the left forever, right? But it stops when we get to what x value here? 2. And that's an asymptote, so it can't touch it. It can't be -infinity, and it can't be 2. But I'm not done, because after 2, something happens. After 2, x goes from 2 up to +infinity. So basically, my domain gets split up into 2 parts. This is the math way of saying x can be everything except 2. Okay? So it can go from -infinity up to 2, and then it goes from 2 up to infinity, but it just can't touch that 2. So it's almost all real numbers. It just can't be 2. All right, and you would do the same thing with the y value there. So the y value would be, yeah, because the graph, look at your picture. How many pieces do you see? 2. So since our graph has 2, and that's a tough one because we didn't do an example like that, but now we know that if the graph has 2 pieces, you have to have 2 parts to your domain. Same thing if you had a graph that was broken up into 3 pieces, you would need to have 3 statements of your domain. So for my range goes from the lowest point is -infinity all the way up to 0. But then the other piece, my lowest point is 0 all the way up to +infinity. And that's just the fancy math way of saying everything except 0. Okay, so that's domain and range. All right, let's talk about evaluating functions and finding solutions here. We're going to switch gears here a little bit. Evaluating a function is where I give you an input and you find the output. Finding a solution is where I give you an output and you have to work backwards to find the input. So it's just which one I give you. So let's go ahead and do that here. Example 2, say f of x is equal to 2x minus 3. Number 1 says f of 3. So what is that 3? Is that 3 an input or an output? So I'm going to plug in 3 for x, right? That's what it is. So when they give you an input, you plug it in for your input variable. And so what's my answer? 3. 6 minus 3 is 3. Now let me ask you, since I gave you an input, what is this? Is this evaluating or solving? Look at your last slide to be sure. Solving? It's evaluating. Let's take a look. When you're given an input, you're evaluating. That means you're just plugging a number in and getting an answer, right? Finding a solution is when I give you the output. All right, let's do another one here. So here we plugged in 3. Now in this case, it says f of x equals 8. Okay, what equals 8? F of x, right? So am I going to plug 8 in for x? No. I'm going to replace f of x with 8. Okay, so in this case, you're plugging 3 in for your x. In this case, when it's written like this, you're replacing f of x with 8. And in this case, this is solving. You have to solve for x now, right? Yeah, Xana, what's up?
So for one, we use the same equation, right?
Yep, I'm just showing you an example of solving and evaluating.
So for one it was 2 minus 3.
Yep. And this was solving.
Is that what you want to do?
The first one was evaluating, and the second one is
The output is given?
yes, very good. So if they give you an input to plug in, that's evaluating. If they give you an output, and you put that where the f of x is, you're solving for x. Okay. Any questions about that before I erase? Is anybody still writing? Okay. Pause for a second. Okay. You guys go ahead and do number 1 real quick, and I'll call on you to start your answer. I'll give you like a minute or 2 here. So John, tell me what I would write here, John Guillen.
Right here, you would write g of x equals 9, and then for the x you plug in to -3 plus 5.
Good. The only change I would make is you said g of x.
Oh,
We are plugging in the 3, right? So in this case, we're plugging in the -3. Did you get the final answer?
yeah,
What'd you get?
-22.
I'm not too worried about the final answer here. I'm just worried about you guys understand the notation. If you see the -3 in parentheses, that means plug it in for x. And John, would you say this is evaluating or solving?
This would be about
Yeah. Yeah, Xana, what's up?
Do we have to plug in -3 twice? One with g and then one with 9?
Well, it depends on how you feel about it. They already plugged it in for us. But technically, yes. I mean, you should, if you started up here with the g of x, yeah, it goes in both spots. Everywhere there's an x, you put that -3 when you're evaluating. All right, number 2. Once again, I don't really care if you solve it. I just want you to set it up for me. So go ahead and set it up real quick. Well, think about your answer. You don't even have to write it down if you don't want to. Sam, how would you write this one for number 2? Well, it's right here. So we have g of x equals. There we go. That's it. So in this case, you're replacing the g of x with -3. So you're taking this and replacing the g of x with -3. And that's an example of evaluating or solving. Okay, we're going to stop there because I really don't care about the math at that point. I just want to make sure you guys understand the vocabulary and what the symbols mean. This means plug in 3 for x. This means replace the g of x with -3. Okay? So that being said, let's go ahead and take a look at our last example here. Evaluating and solving with tables and graphs. So first of all, I want you guys to, and I'm going to be going a little bit quick here, so try to keep up with me. We have a table, which is for the graph for the function f, and then we have a graph, which is for the function g. I've got two different functions here. All right. So this first one is asking about which function? F. All right. So this is a 0. Now, that is a what value? Is that an x value or an f of x value? That's an x value. So can you guys find where x equals 0 on the f function? Here's your f function, right? Can you see where x equals 0? Right there. What's the answer? None. Let's jump down to number 3. We'll still talk about f here. This says f of x equals -3. Which row am I going to look at this time? You look down here. So where does f of x equal -3? Right there. And so what's the x value that goes with that? 2. So you guys see the difference? When it's inside, that's an x value. When they write it like this, that's a output value. All right, let's do another one here. Now let's look at g. We're going to look in the graph. So the zero's inside the parentheses. Is that an x value or a y value? That's an x. So let's find where x equals 0. This is a little bit trickier. Here's my x-axis, right? You guys, you agree right here is where x equals 0? Now we have to go up to where our line is. It's right there. So at that point, we have an x value of 0. What's the y value that goes with that? It's 3. Let's do another one. G of -4. Here's g of -4, right? Now there's 2 points there, but one of them doesn't exist. So I can ignore this one, right? So let's go to that one. At x equals -4, the y value is 0.
So, isn't that x-axis, right?
For this one, why am I looking at the x-axis? Because these are x values, right? So now let's take a look at number 4. I'm going to switch gears on here now, Xanim. In this case, here's my x, so this must be a what? That must be a y value. So now you're going to look at your y-axis, right? So let's find where y equals 1. That's here. Now I have to go to where my graph is. You guys agree that's right there? So what's the x value that goes with that? -2. So it's all about just knowing, is this number an x value or a y value? What's the other variable that goes with it? Let's do one more. Is that -4 an x value or a y value? Okay, so let's go to -4 here. Now my graph, is there anything over here? Is there anything over here? There's not. There's a point here, right? But does that point exist? What do we say? No solution. There's no answer for that. There is no way that g of x can equal a -4 because there's only one place where that could happen, and that's an open dot. So there's no answer for that. G of x cannot equal a -4. There's no solution for that. Okay? Here's one for you guys. Go ahead and go as far as you can. I'll spit the answers up there in a minute. You too, man. Bye.